Hello, Elder students. Mr. Laurence here, and I don't know if you know it, but we're getting down to the home stretch. We've only got about 8 school weeks left. That's counting the week we're in D.C. Ladies and gentlemen, it is not time to go on break. It is time to buckle up, buckle down, however you want to say it, and get moving. We got a lot of work to do. We need to do our best. We are not on summer break yet. You need to come back strong. This is the first video since we've come back to school. You're having a quiz on Wednesday. It's going to be over these types of problems. So I'm hoping that you're doing your best. Those of you that are kind of taking time off and, oh my goodness, you're just going to have such a rough time this quarter and your grade's going to drop. And, well, I hope that doesn't happen. Anyway, let's get down to it. So I'm going to do 2 types of problems. I'm going to do a chemistry problem and I'm going to do a mixture with something costing price per pound. Okay, they're the same problem. They're the same problem. They're done very much the same way. Well, let's see here. Dr. Kaboom needs to make, there should be an S in there, sorry about that, needs to make 250 liters of a mixture that is 20% acid. He has 2 bottles of acid, one that is 25% acid and one that is 12% acid. How many liters should he use from each bottle in order to create the desired mixture? Well, it looks like a table. Yeah, well, what are we going to be talking about? Well, in our table, we're going to be talking about bottle 1. Oh, that's in the fat pen. Let me get the skinnier one there. Bottle 1. All right, and bottle 2. And then I'm going to have my mixture. Yeah, chemistry problems are just mixture problems. So let me see here. I'll make that a little bit bigger so I don't have to cram my table down. And all right, so mixture, we got bottle 1, bottle 2, and then what do we care about? Well, let's see here. First of all, we're going to care about the liters. The liters from each bottle, right? And then we're going to care about the percentage of acid. And then the liters of acid. All right. So something like this. So I can fill out my table now. I think he needs 250 total liters, right? Yeah. Well, how do we get those 250 total liters? We take a little from the first bottle, a little from the second bottle, and we get 250 total liters. All right, percentage of acid. Go back to the story. Let's see. First bottle is 25%. Second bottle is 12%. And we know that the mixture needs to be 20% acidic. Okay, how many liters will we get from the first bottle? Well, liters of acid, that is. Well, we'll take the liters that we use from bottle 1 and we'll multiply by 25%. How many liters of acid will we get from the second bottle? Well, we'll take the percentage of acid and multiply by the number of liters. If we did that here and here, pretty likely we're going to do it here as well. Oop, that should be a 250 in there. All right, I've got my 2 equations, but I think before I do it, I'm going to change this. 10% would be 25, so 20% would be 50. All right, so my first equation is x plus y equals 250. My second equation is 0.25, 2500ths x plus 1200ths y. That's going to equal 50. Now I'm going to look at these numbers and I'm going to use my number sense. I am going to solve for x in the first equation. You know why? Not because it's easier. It is pretty easy to do, but because it'll be easier to multiply a quarter, 25%, by x than it will be to do 12%. That's why I'm not solving for y. So x is going to equal 250 minus y. 0.25 times 250 minus y. That's going to equal 1200ths y, and that'll equal 50. Whoa, I have a mistake there. That's not equal to, that should be plus. Sorry about that. So there were my two equations. I solved the first equation for x, and now I substituted it into the second equation. So let me see here. 55% would be 12.5. That should be 62.5 minus 2500ths y plus 1200ths y, and that'll equal 50. Now I'm going to skip a step here. I'm going to subtract this and combine those at the same time. And when I do that, and you really should be able to do that by now, you should be so good at solving equations that this should not be too big of a deal. All right, and so I'm going to divide each side by 1300ths, negative 1300ths to be specific, right? And I'm going to go ahead and grab my calculator, and I'm going to get that the liters from bottle 2 will be about 96 1500ths liters of the 12% acid. Okay, now to get my other one, I'm just going to use x equals 250 minus y. Well, there's y right there, 96 1500ths. So 250 minus 96 1500ths. And so then x would be approximately, it's a rounded answer, so it's off by a little bit, but pretty darn close, of the 25% acid. Now think about if our answer makes sense. If we had a number line and 25 was here, 25%, and 10% was here, right? And so then 12% would be very close. We're looking for 20% acid. Wouldn't it be like maybe here? Maybe, approximately. So look at the distance. They are in a number line. I'm going to need way more of this one than I will of that one. I only want to water it down, so to speak, by 5%. So I only want to use a little bit of this one. All right, the 20% is closer to the one you use more of. All right, okay, let's look at the next problem. Ground turkey costs $4.20 per pound, and ground hamburger costs $2.55 per pound. Susie needs 30 pounds of a turkey hamburger mixture. I'm not going to make a table on this one. I'm going to go right to an equation. I'm going to go, let me see, I don't want to use X and Y on this one. I want to use H and T. So I'm going to do turkey plus hamburger needs to equal 30. That's equations all in pounds. The pounds of turkey plus the pounds in hamburger has to equal a total of 30 pounds. Make that T look like an anchor so that way it doesn't get confused for a plus sign. All right. Now hamburger costs $2.55 per pound, and I need H pounds of it. Okay, the turkey costs, what was it? Was it $4.20? $4.20 a pound. Together, I need it to be $3 times the 30 pounds, right? Because this is going to be the money I spend on the turkey. $4.20 per pound times the number of pounds. If I get 1 pound of turkey, $4.20 will be required to pay for the turkey. Now I'll need money for the hamburger too. Okay, so I take the price of the hamburger and I multiply by the number of pounds. That tells me how much money I need from the hamburger. Altogether, that will give me, it would be the same as spending $3 on 30 pounds. So this will come out to be 90. So, excuse me, I think I'm going to solve for T on this one. T is going to equal 30 minus H. And so I'm going to have 4 2/10 times 30 minus H. And I'm going to add 2 5500ths to H. And that'll equal 90. All right, so 42. It's just not making sense. Hold on a second. All right, 126. There we go. I came up with the right numbers, but the decimal point in the wrong place. All right. Again, I'm going to skip a step just like I did in the last one. I'm going to combine these two and subtract 126 from both sides. So I'm going to get negative 36 and it's going to be 1/65 h, and so I'll divide both sides by 1/65. So h is going to equal, and it should be a negative there, shouldn't it? Yeah. All right. So h is going to equal 36 divided by 1/65, which comes out to be about 21 and looks like it's going to be 9/11. Yeah, 9/11 pounds. Get rid of that decimal point. Pounds of hamburger. So if I subtract that from the total of 30 pounds, that would mean that the turkey is going to be 8 2/11 pounds, right? Because this would make one whole, that would make 29, 29 and 1 would make 30. All right, there you go. That's your video. We'll have a little quiz on this on Wednesday. Mr. Laurence signing off. Goodbye, everybody.